So, welcome members. Today we are going to see how do we handle coplanar planes and the collinear planes. But please don't forget to subscribe to the channel. Now, if vectors A, B, and C are coplanar will mean that they are in the same plane. Now, assuming I have a plane like this. So I assume that there is a vector A, there is a vector B, and there is a vector C. So if they are in the same plane, we say that now they are coplanar. So now that means that if A, B, and C are coplanar means they are in the same plane, then C, you can get vector, one of the vectors, and express it in terms of the other two. So where K1, K2 are real numbers, these are scalars, they are constants. Now, it means that now, if these constants are consistent through the equations that are going to form, then it means that those vectors are coplanar. For example, we have a number here. Show that the vectors, this, and this are coplanar. It means that now, there exists two constants, K1 and K2, such that C will be equal to K1 of A, then plus K2 of B. It can be A equal to K1 C plus B. It can be B equal to K1 A plus C. Sorry, you can mark it interchangeably. Now, from here, is that our vector C here, if I wanted to do a column form, is that it has no I, so it has 0, then 7, then 5, now A, it's here. Now B, negative 1, 2, 2. So after writing them as a column form, now I form equations out of here. So see that from here, my 2K1 minus K2 is equal to 2 and 0. Then now from here, we form these equations like that. This is equal to this times this, plus this times this, and so on. So if I name this equation 1, equation 2, and equation 3, now our task is to get what the values of these constants, and after we check for their consistency in equation 3. Now I'm going to say, you see, I need to multiply here by, let me move K2, I need to multiply here by 2. So I'm going to say 2 in equation 1, because the signs are different, I add now equation 2. So let me multiply here by 2, I have now 4 K1 minus 2. Now that one we are going to add because the signs are the same. If I add this one, I get 7 K1 equal to 7, and from there that my K1 is equal to 1. From there, we start your K2. If we solve, so that when we put here your K2, because this one is 1, this one is 1, you'll be having now your K2 as a 2. Now, we check for their consistency. We check consistency using equation 3. So we said from 3, now I come to this K1 is equal to 2. I want to see, is it consistent? Now you put the values. The values you are putting should be able to give you this value which is 5. So from here, you see that we got are 5. This plus this was giving us 5. So let us see. K1 is 1 plus 3 into K2, which is a 2, which will be 1 plus 4, which is a 5, which we have left side. And you see that now we conclude that since K1 and K2 are consistent, then vector A, comma, B, and C are coplanar. So there, you see that they are coplanar. You always get these two equations, all of them to get these constants. After getting these constants, now put them in equation 3 to check for their consistent. Constant means that always the left hand side, when you substitute the values of constants, it will be giving you the right hand side. You see that here when you substitute in K1, it gave us the right hand side, so it's consistent in all the 3 equations. Now, collinear points, here now the difference here, if we have collinear points, it means that those points are in the same line. Assuming, for example, if this is a line, and I have a point A, B, and C, if these 3 points are on the same line, we call them collinear points. Now, so that they are collinear, you just get displacement between these points and show that these two, the displacement between the vectors you've got, one of them can be expressed as a scalar multiple of the other. This is what we mean. If A, B, and C are said to be collinear, if this one is the same, which means there exists a constant K such that AB is equal to K, a constant BC. Where instead of just saying the vector AB, then is equal to a scalar multiple of BC. If you can express this, it shows now that those points are collinear. Now, the other thing is that if these points are in the same line, they are going to be parallel to each other. So this will be parallel to this and will be parallel to this. They are parallel to each other. In simple terms, this is the condition that shows that those vectors are parallel. So let us see. It means that you can form, or you can, any vector can form AB equal to KBC, or you can form AB equal to KSC, or you can form SC equal to KBC. It's up to you. So now, here I need to get vector. So I said I have vector, I have points A, B, and C. If I form vector AB, so my AB, I want now to form a vector AB, which will be OB minus OA. Here I have my OB as 5, negative 1, 3. Then minus my OA, which is 3, 0, 2. If I subtract these ones, this that I get 2, negative 1. Then this will give me a 1. Then I also get BC. I can get it. I have got AB, then I'm going to get BC. So for you can get SC. It's up to you. So now my BC or B. My OC is here. Minus OB, which is 5, negative 1, 3. Let us see. If we simplify up there, is that we have negative 1 minus 5, negative 6. 2 minus minus, and get 3. 0 minus 3, and get negative 3. So now you check, it's that here, it's that our BC is here. Now, it's that your BC, which is equal to negative 6, 3, negative 3. You see that here there is a common constant. You see that there is a negative 3. So if I factor out negative 3, I'll be having here 2, here negative 1, and here a 1. But you see that negative 3 into the whole of this is what? The whole of this is our AB, which is AB. So meaning now, this one shows that these points are collinear because I'm able to express two vectors from those points as scalar multiple of the other. So remember, that's how we handle coplanar and collinear points. Don't forget to subscribe to the channel. I wish you the best.